This is a photo of volcanic lightning. It was taken by German photographer Martin Rizzi, and it prompted us to ask, how the heck does lightning happen? Hey guys, Trace here for DNews. Lightning is a beautiful phenomenon. It's associated with summer thunderstorms and sometimes crazy stuff, but volcanic lightning? What the heck? Magma? Explosions? Heat? Lava? Explosions again? Lightning? You're getting a little melodramatic there, Mother Nature. With surface temperatures that are hotter than the sun, lightning bolts seemingly come out of nowhere. They strike objects tall and small alike with up to 1 billion volts of electricity. Do you know what causes lightning? Are you positive? No, but really, are you positive? Lightning strikes somewhere on Earth 100 times every second. Scientists are pretty sure lightning in thunderclouds is caused by something called charge separation. Hopefully you already understand what the water cycle is. You know, water evaporates out of lakes and streams and rivers and whatever, and condenses into clouds and then rains back onto the surface again. The water cycle. Clouds are just a collection of these little drips of moisture condensed around tiny particles floating in the air. It's the particles that cause all of that electrical fun. The particles fly around, bumping and shaking inside of the cloud, and as they hit each other, the atoms bounce electrons off of one another and build up electrical charges. This is called ionization. Once the ionization reaches a certain level, the electrons start to reach out for the ground, sweeping along the air looking to connect. The name for these invisible trails of electrons are called step leaders. These step leaders are looking to equalize the charge separation of the negatively charged cloud and the positively charged Earth. If you saw my video on the power grid, you know that the electrons want to escape ASAP. But it's not just the cloud. The stuff on the ground is reaching out too. Like when you rub a balloon on your hair and the hair reaches out toward the balloon, it's kind of the same thing. It's responding to that opposite charge. So trees, buildings, mountains, people, ice cream trucks, they are all sending out streamers of positive energy. When the two of them connect, the cloud discharges all of those electrons into whatever streamer meets the first step leader. The instant a connection is made, positive energy flies up to the cloud from the Earth to equalize the charge, and the negative energy comes back down again. It's not really in a single transaction. This happens repeatedly, really, really fast, and these strokes can happen over 24 times in a single strike or connection. The flash that you see isn't electricity, it's actually an explosion of heat because the moving electrons get so hot that they cause the air around that bolt to explode, which in turn causes thunder. Now that we know where lightning comes from, what about volcano lightning? Because of the threat of conflagration, scientists can only theorize here, but the large clouds and fast-moving exploding rocks are thought to create a similar electrical charge to a thundercloud. The aerodynamics of the positively charged rocks and magma flying into these negatively charged clouds of ash and dust over and over again cause chaotic levels of rapidly evolving charge separation. It's like a thundercloud on steroids. The step leaders meet the streamers over and over and over again, causing the stuff of nightmares. Are you afraid of lightning or do you seek it out? I mean, personally, I love it. I think it's fantastically beautiful. But if we could just harness that power, that 1.21 gigawatts, and direct it right into the flux capacitor. Light up our common areas with your thoughts, and be sure you tweet at us and join us on Facebook and Google+ so that we can continue this conversation. Thanks for tuning in. Stay positive, everybody.